So if you want to follow up with me electronically, so you know where I am, um, you guys, if you want to electronically, if you want to follow up, and also you have a copy of it, I'm in the instructor folder, and you guys have access to this. And we went over the residential stuff, right? I'm going to walk you after I'm done. So I'm going to do the commercial today, and I'm going to walk you a little bit through the Revit families later on. So I'm going to go to the commercial. I'm going to start with the lab. So I'm going to go over the lab. And when I go there, work, scope, and schedules. This is where I am. So I'm going to be looking at these documents. You guys have them, a copy right in front of you, and you can also have them electronically if you so decided. The document that I'm looking at right now is the schedule, right one. The one that's open is right this one. Cool? Everybody's okay with that? Where we are? All right, so let's go. There you go. Our commercial project, guys, um, it's going to be a 12,000 square foot commercial office building. It's Hallberg Engineers Office. So you're going to be touring that office yourselves. You looked at it, the picture right behind you, that big office in the corner, that 3D green background. That's the office I'm going to be doing. 12,000 square foot. Um, Strictly office, no data centers or anything else, with support areas as in bathrooms and hallways and utility rooms. Every building that you walk into, guys, they have to have support area, they call it. These are the bathrooms and utility rooms, and hallways. And then other rooms that use for other application, mostly offices. So or manufacturing section, or data center section, or lab section. These are the specialties that they have. So our commercial project will be, I would say, 90% office, and the rest 10% are support areas, bathrooms and hallways, and utility rooms. Here's the schedule that we'll be doing, guys. You might have to adjust it as we go. The schedule is dynamic because we have a lot of speakers. Sometimes they cancel, so be aware of that one. So they might have to reschedule. Since I printed it to you, here's the changes, guys. So we are in week number 1. We're going to do project introduction today. That's what I'm doing. And we're going to do Revit fundamentals. Today, tomorrow, and Friday, we'll talk about Revit fundamentals. We're not setting up anything. We're not going to do the project yet. We just talk about fundamentals and understanding gravity. Halberg was supposed to be here tomorrow. They apologize, they can't make it. They have a project, so they rescheduled on August 28th. So if you guys want to grab the 24th and just stick it on the 28th, put 28th, and that's the only change that we have. August 28th. So this project is 100% adopted by Halberg engineers, meaning once a week they will be swinging by, one or two of their engineers, and overseeing your work. So it's really nice connection with them. You have another set of eyes to look at your work, instead of just Chad or Mashad Cooley. You can see how different people do it differently. I think you guys will benefit a lot from it, and the students over the years have done. The project, my friends, is Project Revit MEP Drone. This is a strictly Revit project, MEP. We will have 10 sheets, or when you add the sub sheets, we probably end up with 14 sheets. We call them E1 through E10. So next week, as you guys can see, when it comes to next week, we're going to be doing setting up a Project Revit setup. So that's the major thing that we're going to do next week. We'll on Monday, I'll walk you from A to B through the linking process, through setting up the sheets, through editing your tile block, and the whole big spiel. Though this week we'll just talk about the fundamentals. What is Revit? What's the difference between Revit and CAD? So today, guys, at the end of when we start Revit, I would like you to open CAD and Revit. So I'm going to be opening CAD and Revit to compare the two together. It's really nice. It makes you understand both. Because that's why people are so, I don't know Revit, because you don't know how to compare them. If you can't compare and contrast, you learn and understand both of them. Easy. Okay, so that's what we're going to do. Halberg will be here, guys, on the 28th, which is a Thursday, I believe. Is that Thursday? 28th, yep. So next week we will be doing, like you see, a project setup, Revit. And I have details for that one. The week after, week 3, guys, we're gonna do MS project schedule, Microsoft project. So we have 3 days to finish. And by the way, when I say a week, these are 3 days, 3 working days, right? Everybody understand? So we have 3 days to do the setup, 3 days to do the Microsoft project. That's ample amount of time, guys. By the end of the day, it should be done. Your Microsoft project should be done. Have you guys done Microsoft project? I'll walk you through. I'll give you a sample. It's really not hard. We'll go over it. What does it mean? And we'll create a Microsoft project for design build, and we're done. Okay. Then week 4, Color Hammer was supposed to be guys here in week 3. They apologize. They can't make it. So I rescheduled them into the 9th. I don't know if you can see. So on week 4, we're going to do electrical load calculation, detailed calculation for the commercial building, guys. At the end of the 3 days, you're going to give me an Excel sheet with math that does the load calculation. I've showed you some of the load calc. And also, we will be on September 9th. It's not Monday. That's a Tuesday. Even though it's not like a commercial project, we're in the residential. But for the speakers, guys, whatever fits them, I allow them to come. So we're going to have a power distribution speaker, Todd Christensen, expert in the power distribution, transformers, and panels. Anybody did you meet him at Michelle? Todd Christensen? Yeah. So he goes there. So he will put a great presentation about the power distribution system. And by the way, all these presentations are on YouTube, so you can go there and type Color Hammer on my YouTube and find it too. But you'll have a live one. And also we're going to be, Hallberg will be coming September 12th, as you can see. And they're going to talk about riser diagram speaker from Hallberg, typically Joe, and talk about what's a riser and how do you build a riser for your building. So is yours colored, guys, like mine? Yeah. So the red means an outside speaker, so you know. Black means an activity. Red means outside speaker. Blue means Hallberg, if you guys want to kind of at a glance. Green means holiday. There's a green also. There's a few greens on there. Yeah, green means a holiday. So that's how I color code them. Any changes on my screen here, I scratch it and I put this. What color is this? Purple. I will put the purple. Purple is a change. It's not in yours. That's kind of how I color code them, so you understand and I understand. Okay, so week 5, we're going to have riser diagram modeling. You guys are going to build the riser, E3. And we have Jerry Stanson from motor control speaker from Square D is going to be here. Moving into week 6, guys, we're going to have riser diagram drafting. You're going to do the drafting on the riser diagram, E3. And we're going to do questions and answer for Hallberg. You can see the Hallberg is going to be here. Week 7, we have floor power receptacle layout, and we will be talking a speaker visual software. Andrew Murphy from Davis and Associates, graduate of this program, will be here to walk you through how to use visual software. Like I said, there will be 8 to 9 softwares that you guys are going to be using. So, anyway, so week 8, moving on, we're going to have floor plan power mechanical equipment, E6, that we're going to be doing. Questions and answers on the 10th. Week 9, we're going to do the lighting for the first lighting visual software. So you're going to do, remember these stuff that I showed you guys, how you put them in visual and you build them? That's what you're going to do. And we do have lighting control speaker, Keith Severson. He will come and talk about low voltage control system. Great presentation. And then moving on into week 10, we're going to have lighting Revit MEP. Now, lighting, guys, is 2 stages. First, you do the visual, then you do the Revit. Right? Everybody says, I can't do lighting in Revit without going through lighting software like Visual or AGI. So then we move it to Revit, and we do the Revit lighting. Hallberg will come here at 24th. Week 11, site plan visual software, E4. So we're going to do the visual for the site plan. We do have an occupancy sensor speaker, Kevin, from Davis and Associates. Then week 12, we're going to do the site in Revit, lighting and power. And we do have Hallberg coming on the 7th, as you can see. Floor plan low voltage E7 and low voltage system riser diagram 7.1 plus a fire alarm and security speaker um, will be here to talk about these systems. Can you guys see that every time we have an activity, we have a speaker that comes and kind of hit on it? Week 14, project energy code analysis. Halberg will be here to look at your work, guys. Generator and ATS sizing. We have Jerry Boggs to talk about generators. Thanksgiving holiday. And week 16, panel schedule, luminary schedules, and relay schedules, and all this good stuff. And Halberg will be here. Week 17, we're going to do power system analysis, short circuit and harmonic, specification, equipment cut sheets, and we're going to top it with a pizza party at Halberg Engineers. They invite you guys when we're done. That will be December 12th, just before the holidays. And week 18, we will do project binders and presentation, and December 18 will be the date for our presentations. So we have a full, complete schedule. Does that make sense? Is that a good plan? Everybody's good? So, as some, I'm going to tell you guys, some speakers will reschedule, so I'll let you know immediately when there's any change in the schedule. Okay. Any comments, guys, about the plan for the commercial project? That's full plan, large speakers for our commercial project will be here. Okay. So let's. So this is the first page. If you guys go to the second page in your binder, the second page is actually a second document here. It's called Final Design Build, right here. So I'm going to walk you. Okay, there you go. So do me a favor, if you guys go to this document again, this is the second tab in your book, the second tab, the second document, second tab, first tab, second document, first tab, second document, first tab, second document. Okay. 2110 Final Design Build project. This is what the expectation is when you do this project. So this is what we expect you to do from that one. And I'll talk about this one, guys. We have commercial project consists of the following. You need to do a Microsoft project. You need to do a load calculation, as you know. You need to do design, everything based on Revit, right? These are the activities. Energy code. You need to do lighting calculation based on visual. Do you see the softwares? Each one of these is software. Generator sizing based on comments, power system analysis based on SKM PTW, specification, just read and understand, this is a CAD, cut sheets from the internet, and you're going to do presentation, and everything that you do, you're going to put a digital copy in your network, on the network for your friend chat, and a binder at the end. So these are 12 points, summarize everything they're going to do in this project, from softwares into activities into binder. Does that make sense? Then you dig deeper and you're going to talk about the requirement right here. Commercial building will be constructed according to National Electric Code and the attached specification from Halberg. Separate lighting and power branch circuit, separate light and power branch circuit. So these are, as we go through, guys, you got to read these ones. So we have the NEC code book and Halberg specification, as well as, I don't want you to make, in commercial building, they don't mix lighting and you probably don't know much about branch circuits yet, but when you do a branch circuits, you don't mix in a commercial building a lighting and a receptacle. So separate circuiting. Project schedule, and I'll go over these in details when it comes. The project schedule, guys, we need to do. Schedule should be the major task. You need to have a major task to install and design the building under the project schedule. And I'm just going to scan through these because these are the activities that we do when it says this week we're going to do project schedule. I go over them in details. We do have 3 electricians with 6 apprentices right here doing electrical work for us with this amount of dollars given. This will help you guys as you do the estimating later on, and it will help you to assign your labor in your Microsoft schedule. So they'll ask you when you assign a labor, your crews to work on the project, Microsoft project, you need to know how many people are there. So that will help you, the number. Okay, Revit. Here's how Revit sheets are going to be. We're going to have 11 sheets, as you can see right in here. where the first sheet must be named title sheet. It will have list of electrical sheets. The bold stuff is the name of the sheet, guys. Everybody understand? That's the name of the sheet. And sheet 1 will be E1. Symbol is sheet 2. Sheet 3 will be power riser. Um, and we have site is sheet 4. Sheet 5 will be floor lighting. Floor power will 6. 7 will be floor plan system. Low voltage system riser is 7.1. Panel is 8. 9 is equipment. And last one is details. Do me a favor, guys. Right in here, you're going to see I will add the change here right into this one. And it will ask you to do floor plan lighting alternative. We will have an alternative lighting system. So as it comes, if you call it E, if you're going to call it sheet 5.1, if you're going to call it sheet 5.1, and that will be an alternative lighting system that's required by Halberg. And I will remind you as we go through it too. Actually, right here, copy on the spot, might as well do it. So if you put it 5.1 floor plan lighting alternative. Okay, so we're gonna have 2 floor lighting, 1 regular and 1 alternative. Do you guys know what an alternative is? You can get this fixtures, you can buy an $80 fixture and give him a layout based on the $80 fixture, and then you can buy a $200 fixture and give him a layout based on a $200 fixture. So give him options. So that's what we're going to be doing. Yes, for saving money. Okay, so these are your sheet that you guys are going to be setting up next week with me in Revit. Any comments, any questions? Make sense? Okay, so please make sure you added that sheet that we just talked about. Okay, moving on to in the same document, Revit MEP drawing setup. This is just walk you again. I'm not going to go over details on them, guys. It will show you what do we mean by setup. So next week when we start setting up, basically I'm going to grab a title block. You're going to grab a title block, pick it up, edit it, put picture in it, a logo for your company, edit the contractors, and create sheets. And you're going to drop views into sheets, and it might not mean a whole lot to you guys. That's what the setup that we're going to be doing. We're going to be linking, I already linked the architectural file to your file they're going to be working. So I'll be talking about this one later on, guys, this week and next week, about the linking and the setting up. So keep in mind. Families. I'll show you the families that we have. Families are symbols. So Jay, my friend, I was just telling him, when I walk you today through Revit, I'm going to have Revit and CAD open so you can compare and contrast the two. In CAD, we call them blocks. The symbols are called blocks. In Revit, we call them families. Just different names. Same thing. So that's what you're going to be doing when we talk about families. That's kind of the most confusing thing. Family is a block. That's it. Just remember, when you need a receptacle family, you grab a receptacle family. And they call them families because you can have different members of the family. You can have a 15 amp receptacle, a 20 amp receptacle, a 30 amp receptacle. These are families, members of the family. Okay, Minnesota Energy Code. We will be using ComCheck, guys, to do the inside and the outside for Energy Code. I do have link for you to download these files. Load calculation. For the load calculation, I have some description for load calculation, but typically here's the 3 load that you need to do. Main panel, receptacle panel, lighting panel. These are 3 separate panels going to be installed in your building. You guys are supposed to have do them. Look at that 10% growth on that. Again, you don't have to know this information, but be aware when you do load calc. I can't remember which week was that we're doing load calc. You're going to go to that item and read it, and I'll be reminding you guys what the requirement for it. Generator sizing. When we talk about gen sizing, what's the outcome for the gen size? I need 2 reports from the software, and you're going to see so easy to use. I'll walk you through how to use them. One is called load, and the other one is called gen size. So one report tells you, here's the size I want. 500 kW. And the other one will tell you load report. Here's all the loads that you inserted in the software to come up with the 500 kW. So that's a proof that you have done the work for your boss when you were working in the office, and yourself, so you don't screw up. You look at your load. Oops, I forgot the air handling unit. And the gen size is the report that you submit to the contractor, to the vendor, and you buy the generator. Minnesota Energy Code. Did we talk about Minnesota Energy Code calculations? Come check. Minnesota Energy Code, the outcome of the Minnesota Energy Code, guys, will be an interior and exterior calculation. These are just the outcomes. Cut sheets. Here's all the cut sheets that I would like you guys to do for the commercial project. I want to remind you, Tony, that there are two sets of cut sheets, one for the residential, 24 of them, and one for the commercial, close to what, 9 or something like this. They're two different projects, different cut sheets. For the commercial project, you guys are big boys now. You don't need to have a cut sheet about receptacle like we do in residential. Only the major equipment like lighting and power equipment, all lighting fixtures, all mechanical equipment, all electrical equipment like generator, panel, auto transfer switch, CT cabinet, fire alarm, and so forth. So these are the cut sheets you're going to be doing. So when I say go cut sheets, please know there's an item right there. Read it, and that will give you kind of details. If you still, there's still, I would say 95% of what you need in these documents, guys. There's still 5% you might have to ask me, Chad. I don't understand what you mean by this. So lighting calculation using visual. When I tell you guys you're going to do lighting calculation and I want you to print the lighting outcome, what do I want you to print? Here's a LED. We didn't leave anything for so I specified everything, guys, over the years because people get confused. So Chad, I did lighting. What do you want me to print from lighting? Well, here's what you want to print from lighting. One is called first floor plan view with calculation point. So I'll walk you how to set it up and how to print it. And when it's time to print, look at this, check, 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 printed them, done. Am I making sense, guys, with all these softwares? Every software that you use is an outcome for it and what you need to print from it. Here's power system analysis. When we do power system analysis, what do I need you to print from it? All these documents, I want you guys to print them from it. From one line diagram, short circuit, input, load flow, coordination curves for the cooling units, as well as air handling unit, and curves and reports, as well as arc flash label. You guys saw, we were looking at the arc flash label there. These are what you need to print. So when you're done with the software, you're going to make sure this is your checklist. Have I printed this? Yes. Have I touched on each and every one of them? Does it make sense? Okay. So we didn't leave anything for guessing for the most part. Project presentation. You guys will be, like I said, you will be assigned one task of the project for 10 minutes each person. So I will tell you lighting, first floor, do lighting, visual. You'll walk them in 10 minutes through visual. Power in Revit. You walk them through how you did power in Revit. Only one aspect of the project. One of you will be an overall, so one of you guys will introduce the project, walk them through the sheets. Here's sheet 1, 2, 3, 4. Here's what we done. For more details, my colleagues will be giving you the details.
We're presenting one project together. It's not like each person has their own project.
Yes,
you'll have our own part of that.
Absolutely. Absolutely. You'll be assigned one task of the project. So you'll do lighting, he will do power, and we have two projects, remember, residential commercial, so I will be assigning one task for you. Otherwise, guys, it will be repetitive and it takes a long time. And now this will be exciting a little bit. Okay, so this is project submitting, guys. You're to submit a binder. I showed you the binder that you need to do, as well as everything have to be online, digital. Everything that you do have to be digitally saved online. When you guys graduate, most of the people they pull all this information, take it with you. It's a good record of what you have done. It will help you in the field. Here's what your binder is going to look like and the tabs. So I specified what the binder, so it's not when you say, well, how do you want that binder, Chad? Here's all the tabs I want you guys to do. So it's very clear cut, and I do have a sample for you if it's confusing too. We don't want to make it guys hard. We're not here to reinvent the wheel. We want you to provide a professional product. That's the map to provide a professional product. Feel free to take this with you and use it as a map for your own projects if you want. Okay, so that's basically it in terms of requirement for this project. Any comments, guys? Any questions? Comments, questions? So like I said, we have 18 weeks to finish it, 3 days a week. Not 5 days though, 3 days a week. So that's the requirement for, as we start doing the commercial project, that's what you guys are gonna be doing. I'm gonna minimize this document and delete this one. Save this one. Okay, so these are all the documents. So I'm gonna walk you, so we got this one. I'm gonna go to the third document under the same tab, guys. Third document under the same tab. This is this one. It's called CSI 2600. Okay, now what is this document? Scope. When you do a commercial building, unlike residential, the NEC code book, guys, doesn't say a whole lot about a commercial project. If I ask you right now, what does the National Architect Code, how many receptacles the NEC code book require in a room like this? There is no place in the NEC code book that tells you how many receptacles do you need in a room like this. If I ask you, how many receptacles do you need in a kitchen in a dwelling? Residential. Oh, no problem. In the kitchen, on the countertop, it's 2 by 4, every 2 feet from every opening and 4 in between. Very clear. On the walls, 6/12 rule, they call it. 6/12. 6 from every opening, like a door, and in between 12 feet. Done. Very clear. Dwelling, very clear. Commercial, industrial, you guys are going to be doing it. Because of this vagueness in the code, somebody has to come up with a template so we can use. What you're looking at here is Halberg template. When we do industrial project, Gary, we have Mishad Cooley template for the industrial project. This is Halberg template. Without this template, guys, you cannot design the project. You just can't. Yes, this is a guideline scope, they call it. A scope or narrative, the terms that they use for it, project scope, project narrative. The way they come up with this, typically the engineers, senior engineers in the company, they do business like Halberg does a lot of schools. So they get together and they write a narrative like this about a typical school. What would a typical school have? How many receptacles, how many lights, where the switches, a typical. And that becomes their narrative for a school. This is a narrative for a commercial office building. So there will be a narrative for a school, a narrative for a commercial office building, a narrative for a hospital, a narrative for a gas station. Can you see the locations are completely different? Data center narrative. And that becomes the Bible for the design for this firm. And narratives are slightly different from one firm to another, but for the most part, I bet you at least 85 to 90% they're very similar. And they come from industry standards and experience and talking to the vendors and what's not. So you take this with you to the owner and you say, here, if you want to build a school, yeah, in Bloomington High School, yep, here's a template for high school that we built 16 of them in the last 5 years. Are you guys smarter than everybody else? Here's our template, modify it. Or let's go through our template and see what you agree and what you don't agree. If the customers are smart, big cities have their own template for their own schools. They give you, no, we don't want your template. Here's what we want you guys to do. Here's our template. A lot of vendors, like if you go to Home Depot, all these big vendors, guys, big boxes they call them, Home Depot, Target. You guys work with Target, Home Depot. They have their own template. When they go to Mishad Cooley, they said, here's what you want you to do, guys. Here's our template. Go do it. Go design it. Done. We've done them all over the country, all over the world. So if they don't have a template, you create your own and you share with the customers. Am I making sense about the scope of the narrative? Okay, Halberg is going to talk to you about this, so I'm not going to spoil the show for them. But for the most part, guys, you have a 10,000 square foot building with an addition of 5,000 square foot, and you are to design a complete power, lighting, and low voltage system for this building. That's how you start. Square foot of the building is so important, and the type of the building is so important. Is it an office building, or is it a manufacturing building? Is it an airport? Is it a hospital? Your design, your template will be completely different. What I suggest for the students, guys, take these templates with you. If you work in a firm and they want to do an office building, they don't have a template. Here's the template that we use and Halberg does. Use it by any means. These are not secret. Okay, so these are what the requirement they need, basically designing the power system for this building. Moving into the alternative, when it comes to lighting, guys, like I said, lighting can be an $80 fixture above your head or a $200 suspended fixture, decorative type, direct and indirect light. So which one are you going to use? Sometimes what we do when we design, some of the template will have a general cheap lighting system layout and more expensive alternative, or vice versa. An expensive layout of fixture and a cheaper alternative. So this guy is a cheaper alternative. Actually, the alternative right here, we have a cheap, not cheap, but more economical alternative for the lighting system in the open office, which is used 2x4. Like these are, by the way, these are the most economical way of laying out fixtures. That's it, just 2x4, recess cans, 3 lamps, and move on. Easy to maintain, $80, and throw them through your building and move on. So, but if you want fancy stuff, which this project is fancy, you're going to see it, you have to lay out differently. So, assumption, there's a few assumptions that you have to do, guys, about the owner will provide certain things and what's not. And I'll let Halberg deal with that one, but you read through it. They always have regulatory requirements. What do you need to adhere to? Now, remember, this is an engineering template. Look what you need to adhere to. These are, in addition, American with Disability Act. Does it ring a bell to you yesterday when we talked about the lecture, American with Disability Act? You have to meet the American with Disability Act. So you can't put a switch 70 foot or 7 feet above the ground or 6 feet above the ground. It has to be within 42 to 45, I think, inches from the finished floor so people with disability can reach it. National Electric Code, the latest. Life safety. Can you just say it? Life safety? That's where your generator and lighting system comes. State and local codes, uniform federal accessibility code, Minnesota Energy Code, International Building Code with the amendments. So these are the stuff that you have to take into consideration. That's where Halberg comes. For you guys, these are, it doesn't mean a whole lot. When you become a design engineer, you might have to educate yourself on a few of these. If you ever seen them designing certain things slightly different, be aware that there might be a requirement for the building code. For example, you penetrate an outside wall right here. What do you need to do from go from an outside to inside? Anybody remember? But you need to seal it, right? You need to seal because temperature in Minnesota especially, right? Or anywhere else. Very cold or very hot. So you need to seal so there's no transfer of air between the two. So these are require you to seal to use certain wiring methods and certain seal. 1.5 design criteria for lighting. If I don't tell you guys how you're going to design the lighting, no way on earth, Tony, you can design lighting for a commercial building. You just don't know. So look, they have to give you in the template, what do we want you to do? For example, receiving room. These are all the areas on the location is the areas in the building that you guys are going to be designing. The first column is the area. The second column is the required foot candle. Are you guys familiar with the foot candle? Foot candle is like our currency in the US is dollar. In Europe, they use euro. The foot candle is basically the unit of measurement of light. How bright the area is measured in foot candle. To give you an idea, right underneath right here, where you're sitting right in this area, you're looking at close to 75-foot candle. If you go right in that corner where it's dark, you're probably looking at 20-foot candle. Give you an idea what a foot candle is. So that's, and we're going to do, guys, all these visual calculation will get you foot candle. We do have a class dedicated to lighting, so we'll go in details how to do the foot candle, what does it mean, lumens, and what's not. But for the time being, when you use the software, you're going to make sure when you do your calculation, you're going to end up with an average foot candle of 20. You can't make it 40, otherwise you did not meet the criteria. If you end up with 21, 22, I'm typically okay, 19, 18, okay, around 20, but you can't double it, okay? Then, this is the illumination requirement, a fixture type. Not only they give you how much foot candle you need in this room, in the receiving room, but what type of fixture you need to install. It's wraparound fluorescent. That's the type of the fixture. So what do I know, Jay? How do I know that wraparound fluorescent? What we do, guys, we use Lithonia. I will give you a sheet that identify every single one of these type of fixtures with a picture and where you can find them in Lithonia. because you guys have never done that. You can research it, but we make it even easier for that. And where you find the IES file for it. How do you want to control this room, Chad? We need ceiling mounted occupancy system. If they don't tell you how do you want to control the light, how can you decide? The cheapest, obviously, switches like here. They don't want switches in the receiving room. They want an occupancy sensor. You walk in, it turns on. You walk out, after 15 minutes, it turns off. Saving energy. That's what they do in a commercial building. You can't meet the energy code right now, the strictest energy code, without having an automatic means of lighting control lighting control system. Am I making sense about that lighting requirement, guys? You can, I'm not going to go through all of them, guys, but you can see the whole everything. Like, for example, in the conference room 123. And by the way, Gary, when I say 123 in the blueprint, you'll see a room 123. So it's very easy. So where's 123, Chad? Well, when I give you the blueprint in Revit, you'll see 123. So here's the room that Chad is talking about. They need a look at this in this area, because it's kind of a conference room. They need 3 types of fixtures. They need, if you read through it, they need a general lighting fixture in the ceiling, and on the wall washing light. Now we're getting specialties. They need wall washing light. You guys have seen them where they have fixtures and shooting lights on the wall, so it looks cool and nice in the conference room. Now that's where the science of lighting becomes a big deal. Any comments, guys? And how do they want to do it? Look how they're going to do it. They want to have local room dimming. You walk in there, you can dim the wall washing lights, or the normal or the general purpose light. Any comments, questions about the lighting requirement? And remember, when we start doing lighting, you're going to go to this item and read right through it. So, and you can see it goes over each and every one of these rooms. Can you guys see that? All the way to the last one. This is, which page is that? We're in page, the pages are right here in the middle. Can you guys see it? Page 3. Page 3, if you guys look at now we have egress. Look at the last 3. Egress doors, exits, and emergency lighting system. Now, in addition to the general lighting system that you're going to be installing, you have to accommodate for the exit doors, the exit signs, right? And we need exit signs. We need also exit doors, a big fixture right at the exit doors that give you light so you can exit the building. And emergency light. What happened if I lose power? So we need to lay out an emergency. They call it bug eyes. You guys have seen the bug eyes. That's one type of them. Another type is a fixture like this with a battery inside it. So you lose the power here. There's a relay that switches to the battery, and the light instantly comes on. They have many of them. Of course, it costs money, but there's multiple alternatives of meeting the life safety egress light. So again, we'll go over these in details. More details about the type of the light and the lamps, like T8. We're going to be using T8 lamps and these, and so forth. Any question, guys, about the lighting requirement, which is 1.5? Halberg will go over it too a little bit. So questions about that? Now 1.6, lighting control panel. In this building, they don't want to use just a normal 20 amp switches. They want to use a lighting control panel. Do you guys, you were doing PLCs, right? And you have done PLCs. Lighting control panel is basically a PLC panel. Multiple relays with a PLC in it that control all these relays. That's all. You can grab your iPhone and program it through your iPhone. You can send the signal to the lighting panel from anywhere in the world. If your network, they're all networkable, can be networked. So it's unreal. You can have full control. You can dim the lights. You can do anything through that lighting control panel. For this one, we need to have a lighting control panel with relays of 20 amp 120. So we need to be able to turn them on and off with occupancy sensors, timers, and also we need to program them to sweep at 6 o'clock at night. When everybody leaves, say 6 or 8 or 10, whatever, if somebody left the lighting fixture on, it will sweep the light off. You're going to see it's really an interesting way of doing business. It's all about energy saving energy. So that's your control panel, and we have an expert about control panel, guys, that come, Severson, and he brings a panel with him, and you get to push button and play with it. And and look at it and so forth. So that's, look at this, we have a coffee pot because people like Chad, well now coffee pots guys, they are programmed to shut down at a certain time, but in the old days, they used to, this building is built, I think, what, 15 years ago. So in the old days, people used to leave the coffee pot on, like the one that we do, and it burns. Um, the receptacle that feed the coffee pot in that room, they put it, they feed it from the uh, lighting control panel. And at night, after 8 o'clock, it shuts down the light as well as the receptacle. That's how you can shut down certain things. Okay. Anyway, so that's, and we'll go over these in details, guys, at region. 1.7, conference room, 123 local dimming system. It details what they want you to do in the local dimming system, how many zones, look at that, 4 zones and what's not. And I will leave this one to the details as we go through. 1.8 is so important, guys. 1.8 is called design criteria for power. If I ask you, who am I going to pick? So, my friend, if I ask you, how many receptacles do you need, do we need in the receiving room? I don't know, Chad. How many receptacles do you need in the receiving room? I have no idea. Remember, the code doesn't tell you in a commercial building how many receptacles you need or how many lights. The code says you need enough lights for safety, for people so they don't trip and kill each other, walk and trip and break their heads. So you can meet the code, guys, the NEC code book by one fixture. See that fixture above you, Jay? That fixture in this room, just one fixture will meet the National Electric Code. Really? Is that what you're in design? So because of that, then you need a scope, a scope and narrative. Here's your narrative. In a receiving room, we need one receptacle for every 1,000 square feet. Where the heck did they come up with this? Is this an NEC code book? No. Where would you find this one receptacle be 1,000 feet? Experience. Their experience with the receiving area, by making many of them, that's enough. You might go to a Halberg at Mashad and they say, no, we need a receptacle on every wall in the receiving area. That's okay. That's a narrative. So if you go to the owner and say, in your receiving area, you will end up here probably one receptacle in that area. If you say, how many receptacles do you need in the receiving room? Here's what we do, one receptacle. He might say, no, I need a receptacle in every one. No problem. Here's a receptacle in every one. And what type of receptacle do you want him? Standard or GFCI? Now, the GFCI, you can't, now GFCI is specified in the code where you need them. But if it doesn't say in the code, do you need a GFCI or not, this is going to be a standard. Okay, restrooms, we have 113, 114. We need one receptacle per 2 sinks. That's code requirement, and GFCI. They have to be GFCI. Some of them are code, others are driven by industry. Okay, all the rest of them, guys, the same. Look at this one. I have lunchroom 119 vending machine. I need one receptacle standard. Yeah, notes. Can you guys see the notes here? The notes will tell you how do they want you to circuit them. So it takes area per area, how many receptacles you need in area in each area, and how are you going to circuit them. So I mean, it didn't leave anything for guessing here, does it? So any comments, any questions? There are quads, quad receptacle, and we have a quad here. So these are duplex. If you put the 2 duplex together, guys, they become a quad. So when they say a quad receptacle, basically they 2 duplex receptacle. If they say as a receptacle here, 1 receptacle, they mean 1 duplex receptacle. Okay. And there's places where they say, yes, sir.
What was it in the notes? Like, so right there, like, lunchroom 119, what receptacle standard, 6 what?
Okay, 6. Let's go to 6. Here's lunchroom. If you guys look at lunchroom vending machine, 1 receptacle standard 6. If you go down all the way to the bottom, here's note number 6. Can you guys provide receptacle on dedicated circuit? Circuiting or other information. Everybody understand how to read that one, guys? So it makes it, and some of it might, you still have like here, route. Look at note number 3. Look, no, it says route circuit through the lighting control panel for on-off control of task lights. They want to control the task lights because Brandon leaves his task light in the office on all the time and it's consuming energy for nothing. So they want to sweep all the receptacles that feed the task light. Does that make sense, guys? How are we going to lay out our receptacles? Very clear. When I say power layout receptacle, here's the criteria. You're going to go to Revit, start grabbing them. You know, it's really, we made it really dumb proof, or they made it, the industry makes it dumb proof. You don't want to sit there and say, what the heck am I going to be doing here? So, any comments about the receptacle? Please pay attention to the notes here. I'm not going to read all of them. As we go through, Gary, we will be going through these items as you start designing them. But please, before you ask me, guys, read through them. You know, a lot of criteria. You go to room by room, read what the requirement. If it's still you don't understand it, then you can ask me. Building equipment. 2.1 building equipment. The equipment that now the owner have equipment that need to be dedicated circuits, and they're identified by numbers. So, John, my friend, when you go to the layout of the building, you're going to see a box, and in it number 12. Now, what the heck is that number 12? Well, number 12 is say copier. They want a copier there. Here's a copier, like a copier there. So what do you need? If you know there would be a copier there, you need a circuit to feed that copier, a receptacle, in addition to whatever receptacle you have in the area, a dedicated receptacle with a dedicated circuit to that equipment. Fax machine, copier. Absolutely. Look at this. Here's item number 12 is a copier. Item number 13 is a laser printer, fax machine. These 15 and 12 are shelf units, so we don't power shelf units. They're just there, so you see a number, and do I need to worry about that number? No, don't worry, it's shelves. It identifies the numbers that you see on the blueprint that are coming from the architects. So what your job is? Your job is to look at these copy room, print room, all these items, guys, and see, does it need a receptacle and a circuit or not? So like shelves, doesn't. Same thing, print room and all this stuff. These are owner equipment. Office, item number 24 are plan racks, for example. So don't worry about it. Or if they're in one area, make sure you don't put your receptacle right behind them so people don't have access to it. Any comments, guys, about the 2.1? These are building equipment. Okay, moving into electrical service, 2.2. Electrical service, guys, when it comes to a commercial building, Brandon, you can power it with typically 2 voltages in the US. Either we use 28120 or 48277. You have to know that. I have to tell you that. That's the first thing a project manager do when they have a building. They go based on the size of the building, and typically 15,000 square foot or less commercial office building, what they do is they put them in 28120, smaller service. Higher than 15,000 square feet, again, typical, they go 48277. If the load is industrial building, 48277, airports, 48277, these big data centers, 48277. Office building, depending on the size. So in this case, ours is what, 10-15,000 square foot. A good application for it is a good application will be 28120. So important. As a project manager, we decided this one for you. Okay, so that's 4-wire delta, of course. And then a couple of things how they want the distribution circuit. You need to accommodate for the 5,000 square foot future expansion. And then here's all the panels that we would like you to feed and equipment. Look at this. So you bring the service, John, to the building. That's at one big panel. Then from that big panel, the service panel, you need to feed multiple panels. We're telling you that. You don't know, right? We need a lighting panel. Can you guys see the lighting? We need a lighting panel. We need a receptacle panel. And then directly from the main distribution panel, we would like you guys to feed the air handling unit, condensing unit, pump 1 and pump 2, auto transfer switch that's going to the generator, and for future lighting panel and receptacle panel and condensing unit. So future. So that will allow you to plan for the future, meaning you have a circuit breaker that says future condensing unit, future receptacle panel, future lighting panel. Basically, this is your riser. That's how you build your riser. Which is that thing that we talked about, this one right here. This is how your riser is going to be built, based on this right here.
Generally, all that stuff kept in like one room.
Yes, and one electrical room, typical, one room. Now, in a building like this, but the bigger the building, the more you have different electric. What they typically do in a major building, huge building, Riser, for example, they have one electrical room in the basement where the service comes, and then every floor will have an electrical closet, and they have one or two light panels in it, fit from the basement directly, and feed the receptacles and the light and the mechanical equipment in that floor, and they keep going, second floor, third floor, fourth floor, and so forth. Um, so the bigger the distribution system, the more electrical room you have. An office building like this, one story, right? Typically, it's one electrical room. Any comments, guys, about these? Does it make sense? Okay, so moving on into transient fault surge suppression. This is a fancy name for if you get hit by lightning, do you want to burn your laptops? Or do you want to have a little device that's called surge protector device that kind of chop that high voltage? So they're telling you they want this requirement too. We do have a speaker, guys, when power distribution system, Todd comes and talks about it, he talks a lot about surge protector devices. Electrical power distribution system, we're just telling you about the voltages. So provide power to feed the lighting and the voltage system. The one important one is 2.5, mechanical equipment. In every building, Jay, that you walk in, very simple, guys. When you design electrical buildings, very, very simple. Always you walk in, you need a service panel to bring the service to it. It's first panel. Next, you need a panel typically for your lights. Group all your lights in one panel. Here's a second panel. Next, receptacles. You need a receptacle panel, at least one panel for your receptacles. Here's a third panel. Next, now we have receptacles and lights in the building. What else do you need in the building? Think about it. Switches is part of the lights. What load? How about heating and cooling in the great state of Minnesota? How are you going to heat and cool? Do you walk into any public building or private building? It's not heated or cooled. Very few cooled, maybe. Some are not cooled, but everything in Minnesota has to be heated by code. So heating and cooling. The second major load in any building, or the third, first light, then receptacle, then mechanical equipment. Heating and cooling and ventilation. You need to be able to heat the building in the winter, cool it in the summer, and ventilate it. If you don't ventilate, people get sick, right? You have to bring fresh air and pump air and balance the air in the building. That's our friends, the mechanical guys, will do. All these equipment need to be powered by whom? Us. So these are the mechanical equipment that you need to pay attention to. For example, and I'm just going to pick on one, air handling unit. We need, it's a big fancy blower that handles the air. That's why they call it air handling unit. It pushes the air. It doesn't matter if the air is hot or cold. If the air is cold, you got it chills you. If the air is hot, it heats the area, right? It handles the air. It doesn't cool or heat. It handles the air. That's, if you guys are not familiar with that term, that's why they call it air handling unit. It handles the air. If you give it cold air, it handles it. If it gives it hot air, it handles it. Just handles the air. Now which one is going to cool you? The one that's going to cool you is the condensing unit. Now that's your air AC. That's going to cool your building. And look at the AC. Look at, first of all, the air handling unit. They're giving you a 15 horsepower, guys, 28120, and VFD driven, and Division 26 to provide VFD to it. Division 26 is us. So here's the information about the mechanical equipment, guys. This is driven by the mechanical engineers. You will get these information with the mechanical engineers. Our job is to power them. So I want to bring to your attention, guys, that there are also cut sheets. I'll show you the cut sheets at the end for these. So if you just remember air handling unit and condensing unit, these are the ones that I would like you to remember. The condensing unit, they're giving you, look at the amps. We have the amps and the fuse. They typically give you the size of the unit. Does it need a fuse? And what type of controller does it need? And what's the horsepower and what's the voltage? So you can size the feeder that goes to that unit and the disconnect and the starter, right? Air handling unit. What does an air handling unit need, guys? It needs a feeder coming from a panel to feed it. Done. Right next to it for safety, it needs a big fat disconnect so you can disconnect it safely. And then you need to be able to control it. How are you going to control it? Typically VFD. So am I providing the VFD or my friend, the mechanical engineer, is providing the VFD? That's where you clarify between you and the mechanical engineers. In a meeting, a project meeting, they say, are you guys providing it by the manufacturer? So they sort out who's providing what in terms of control for the especially for the mechanical equipment. Okay, so here's all your stuff, all your mechanical equipment, boiler 1, 2. We have gas boiler. We're heating this building with natural gas. So we're not burning electricity to heat the building. We're burning natural gas. We're controlling the natural gas burning by electricity. That's a different story. Like the furnace that we have in Minnesota. Does your furnace work in electricity? Yes. Do you burn electricity to heat your house? Anybody have an electric furnace, meaning you burn electricity? Do you? Well, will you? Okay, electric and gas. Okay, so most of, at least in the metro area here, most of our furnaces are gas. But you can buy an electric furnace that's 60 amp, 50 amp, and 100 amp sometimes. Yeah, so it's unreal. So these are in this building, most of the building in Minnesota are heated by natural gas. When it comes, a lot of stuff they burn natural gas. It's cheaper. The reason for that one is cheaper. Okay, so here's all the pumps, recirculating pump, unit heaters, all the skin gas, exhaust fans. You need to be able to balance the air in the room. We typically, guys, next project I bring a mechanical designer here from Dunwoody. He talks about all the mechanical equipment. Do you guys know how they heat, cool, and ventilate the building? Do you understand the whole interaction? Jay, probably. Did you? Yep. You've seen how they do. We'll bring an expert now into how we put all these together, and I'll walk you guys through it. And how does the air handling unit talk to the boiler and talk to the condensing unit and the exhaust fan? How do they talk to each other? What do they do for a living? So we don't need to know that to design the system, but it's really nice. It makes you a better electrical designer to understand how the mechanical equipments are talking to each other. All right, long story short, 15 electrical items, or 15, I think, 15 mechanical equipment you need to pay attention to when it comes to that building. Power them, give them a disconnect, and give them a controller. Any comments, guys? Any questions? So, Tony, when I tell you now we're going to do a layout of mechanical equipment. No problem, Chad. Let's go to the list. Here's air handling unit from Revit family. Grab the air handling. What size, Chad, you want it? Well, it says 15 horsepower, right? Grab it. It says 15. Dump it. Where do you want it, Chad? We'll tell you exactly what you want it. Drop it. Done. Now, next, we need a disconnect. It says need a disconnect. Grab a disconnect. Put the disconnect next to it. Next, it needs a circuit. Grab a circuit and circuit it. Controller, grab a controller and put it. Done. That's how we do it in Revit. Everything is built for you. Okay, by system. We have a generator, guys, that runs a 28124 wire. And we need this gen. We want the gen. You don't have to have a gen, but we decided we want a generator to back up completely the whole building. Okay. If you read through, it tells you, do you want to back up the emergency light? No, all the building have to be backed up. Okay, security system. Now moving into low voltage. We need to have a security system for the building, 2.7. And here's all the requirement for the security system. What I would like you guys, when Halbert comes next week, they're going to go over this again. So if you have a chance to read all of it, so if you have any questions, clarify it. They wrote that one. We have a main security panel in server 107. They tell you exactly what to put it to. We need door contacts on exterior doors, motion detectors on the corridors, glass break on the windows, and audible alarm, and main staff keypad. That's what we want you to build. Simple, typical security system. Right? It's keypad to arm and disarm the system, a couple of door contacts and window contacts and motion in the hallways. And if somebody, an intruder walk into the room, we need an alarm, audible alarm to scare him or her. Typically him, right? 95% of the thugs are male? That's sad. Okay. So these are what you need for the security system. When we start laying out security system, Brandon, you grab your families and start throwing them, family of a contact, family of this and that, throwing them in that building. Moving into the fire alarm system. We need, here's your fire alarm system requirement, my friends. We need a main control panel, a main annunciating panel, pull station, exterior doors, audible visual indicating devices. This is the fancy name for that boy here, that guy there, right there. And we need visual indicating devices in toilets. In the toilets, do we put a horn in the toilet? They typically don't put a horn. Horns are, there's strobes and horns. Either you can have a horn only, a strobe only, or a strobe horn combo. Strobe horn combo goes typically in hallways and big rooms. Strobes only are bathrooms, you know what I mean? And smaller offices, yeah, and smaller offices. Yeah. Smoke detector, yeah. Smoke detection, we need smoke detection in the whole room, duct smoke detectors, and all this good stuff. So this is a requirement for your smoke alarm. And I'm not going to go through the details. When we go to smoke layout, that's your criteria for smoke layout. Last thing, technology systems, raceways. When it comes to technology, these are TV, data, and phone. How are they going to do it? If you read through it, it says the owner is going to provide it, but I would like you guys to provide the following. So we need receiving room 120, we need one wall phone. And in conference room 123, we need one wall phone, one data outlet on wall, and one data outlet in floor box below table for data equipment. So a lot of details. This is where you sit with the owner and discuss all this criteria. Here's a conference room. This is what we typically do in a conference room. Do you guys like it, or you have your own criteria for conference rooms? If the educated customers are educated, they say no. Throw you is here's what we have, because we're Home Depot. We own the nation almost, and we are smarter than Michelle Cooley or everybody else. Well, some of them are. They have. I mean, Target have one day they have their own criteria, man. They give a blueprint to Michelle and say, here's how we want you to build this store. Michelle, take it, no problem. Get it to the production. Give it to the guys and explain it to the guys and let them go do it. Anyway, so here's all the criteria without going into details. Gentlemen, this is an engineering scope. An engineering scope or narrative, the term that they use for it. If you, probably Brandon, you wouldn't see this yourself as a designer, you guys wouldn't see this. The engineers will have this document. They'll convey this information to you. At one time, when you become a project manager, you will modify these documents. Any comments, any questions, my friends? Comments, questions? Okay, so I hope that will get you excited. Great project. So I'm going to give you, should we give you 5 minutes to stretch a little bit? And then I'm going to continue describing it a little bit. Thank you. Thank you. The last thing I want to show you guys is this document, which is, if you guys look after the narrative, there is this document called cut sheets. If you look at the cut sheets, guys, can you guys see it? Everybody see it? Okay.
It's not really vitally important in your statement.
This one, the second page. Yep, here's the one actually that you're looking at right here. Yeah. Yeah. It's the reason why I group them together. You can take the civil office just to give you, to know which section is it. Yeah. Air handling unit. The good thing about the cut sheets, guys, what is the cut sheet? Mechanical equipment, we get the cut sheets from the mechanical engineers about them. We don't do cut sheets about mechanical equipment. We're not qualified to size air handling units or chillers or exhaust fans. That's not our job. Our job is, after the mechanical engineers size the mechanical equipment, they give us a cut sheets about their equipment. We pull the information from that cut sheet, and we so for example, this if you look way at the bottom, it says motor details. This is for the air handling unit 1. Can you guys see where it says motor details, motor type? I don't care about the motor type, but horsepower. Do you see the horsepower for this motor? 15. And this information is already in the sheet for you. We already gave it to you. But in real, in typical, they might not give you, they might give you just a cut sheet. So you have to go to the electrical information and pull the voltage and the horsepower from the equipment. So I have, look at my voltage. My voltage can go from 200 all the way to 208. Obviously, we're doing 208. So it gives you, the most important thing is, like I said, the voltage and the what? The horsepower. That's the first page. The second one, gentlemen, and this is just a quick view. The second one is the condensing unit. Your condensing unit, this is your condensing unit. The one that I would like you, there's one little correction here. The one I would like you guys to highlight, if you have a highlighter or do it, is the one above the one that we highlighted. So please correct that one. Right here, the one that we'll be using is this one right above it. You guys see that? This here.
Yeah, that's not what I like.
Did I highlight it for you?
You did, what did I highlight it on?
My God, that smarter than I thought I am. Oh, man. Okay, that's I thought, because we used to run this project in 48277 when the cut sheets were made. Then we switched it to 28120. That's why that. Okay, so good. So you don't have to do that. So this is the voltage, and right in here for the air handling unit, I would like you guys to look at the top. Do you see condenser fan, full load amp? The full load amp is for the condenser fan is 6.2 amp. The most important three things that you have to understand. Did I highlight it for you? Well, actually, I wasn't that smart. These are the most important three things that you need to know. Very, very, very important. Unit, full load amp, which is 81, minimum circuit amplicity, and overcome protection device. So important for this unit. So what this mean, guys? So for example, for this unit, I need the overcome protection device is going to be 120, 110 amps. Here's my unit. The cable, my cable have to be sized for based on 91 amps, and my full load amp for this one is 81.6 amps. This is what that means. A unit is 81.6 amps. The cable have to be sized based on 91.1 amps. This is this number here. And the overcome protection device is already sized for you. Again, I'll go over these in details as we go. Condensing units, they give you all the information that you need to size the branch circuit for the unit. So that's right on that vehicle. So please highlight these three. When you do load calculation, the same thing. You want to add this one, so you take the 81.6 multiplied by 208 times 1.73, and that will get you the allocated volt amp for this equipment. So you can add it to the other loads, to the light and receptacles, so you can come up with the size of the panel. So very, very important, guys, to do that. Any comments about the HVAC equipment? I want to highlight that one. Okay, if you guys go to the next one, can you guys see where it says condensing, future condensing unit? Did I highlight that one for you, the new one? Okay, it's highlighted. So the same thing, you need to pay attention to the size and the unit and the minimum. Go all the way to boiler pump. The next page is boiler pump 1 and 2. Can you guys see that? And we have the horsepower for boiler pump 1 and 2, right at the bottom 2. FYI. Recirculating pump, the next page. Recirculating pump. Here's the information about the recirculating pump. It's 112 horsepower. That's a little guy. Okay. Moving on into condensing unit 1 and 2. Condensing unit 1 and 2. I'm sorry, cabinet heaters 1 and 2. Sorry.
These will already placed in there. We're just
Yes.
we're using the risers. We're making the risers and wiring them.
You're getting information from here to size the branch circuits, because we need to feed it. They're placed.
But I'm saying, like,
Unfortunately, in your project, you're going to place them, but in a real project,
on a real project,
they'll place them for
would
you.
already be
Oh yeah.
put in.
If you try to mess with them, you will hear from the mechanical engineers.
Yeah.
It's turfs, man. You can't mess with them. Yeah. But in our projects, because we don't have mechanical engineers, you guys are the mechanical engineer too. You're laying them out. You're just putting them in the building and circuiting them. Okay, so here's unit heater. 1 and 2. Cabinet unit heater 1 and 2. Information about these. And you can see here, here's the info about this particular one, the watts and smaller horsepower. Look at that. It has a heater and it has a blower in it. Horizontal unit heaters. And what are these? Certain areas in the building, guys, because they don't want to bring the hot air to it, it's too expensive. It's just on their area. They have a special heater just to heat the area. I mean, instead of bringing hot air. Data rooms, the air, that's air conditioning, but in the, I think, yeah, you'll see with the receiving area, they don't want to bring the ducts all the way to the receiving area. They must just put a heater there to heat the area, just enough not to freeze, because nobody sits there. So they use them in the mechanical equipment. Exhaust fan 1, 2, and 3, guys. Here's all the exhaust fans, cut sheets about it. What we need is the horsepower. Can you guys see it's highlighted 1/4 horsepower? Oh, to the HVAC, this is so important because that's how they size their building and the airflow and what's not. That's their bread and butter, basically. Yes. Yes, absolutely. They come up with these cut sheets, the mechanical guys. We don't know. You don't. When it comes to mechanical equipment, it's specified by mechanical engineer guys. Then they give you a list or a cut sheet like this. They call it mechanical schedule or mechanical cut sheets. And from this information, you size the branch circuit, the disconnect, and the overcomputation device. And the control, you have to decide. Most of the time, the control is done by the mechanical guys too. Absolutely. Yes. Yes, absolutely. And actually placed too. Like all these mechanical equipment in a real project, they will be placed by the mechanical designers. No. In the project, in our project, guys, you will be placing them. In Revit, they make it clear, guys, in our project, because we don't have them laid out. You will be going and finding a boiler pump from the mechanical equipment and dropping it in the location I tell you where, and circuiting it, because we don't have mechanical engineers. So it's not a big deal, you know. You just drop it and circuit it. AC unit. Speaking of the AC, this AC is for they have a computer room, a data center, little data center, where they crunch their number, and they want a special file. They call it file server AC. Server. In the server, this is a big fancy computer that they need to cool it winter and summer, typically. They cool these equipment. And here's the information about this boy. Look at that. It's full load AM is 12.7. Wire size is 15. Overcomputation device is 15. Can you guys see the highlight here? All what you need. The branch circuit is size for you. Gentlemen, this is what we call mechanical cut sheets. Any comments, guys? Any questions about the mechanical cut sheets? So important. The last thing is Halberg Engineers. This is where the building that you guys are in White Bear Lake. Anybody lives in the area? White Bear Lake. This is in White Bear Lake. You guys familiar with 35E and 694, right? I hope so if you're from Minnesota or the metro anyway. This is where they are. County Road E and Linden. You drive. We're going to be visiting them, coming all the way, and this is your office. That's where the building that you're designing is. So you can get information and what's not. This is the map that we're going to use when we go drive there for our pizza. We celebrate when we're done by having a pizza party there with them, and we tour the building. The nice thing is you will tour the same building that you design. So file room, file server room, and shipping. You will walk into all these rooms and say, wow, it looks bigger on the paper than on real life. So it's really nice after you design everything and you walk in the building and see it's designed slightly different. Said, wow. So, okay, so that's basically, guys, it in terms of the project. Any comments, any questions? The project. I would like you guys to go to tab number 3, please. Tab number 3. And I want to look at the syllabi because this is brand new class. Here's my syllabi for this. The first document is a syllabi. Same information about me and location, all the stuff. This is Wednesday, Thursday, Friday class that you guys know. Um, it's starting, the lab is, this is our lab, the commercial project. It starts from 9:30 to 12:25, like you said. What's the outcome of this and why are you guys coming here? You will be designing a complete power lighting and low voltage using Revit for a 12,000 square foot commercial building. That's it. With everything supported. Um, I'm going to go all the way to the competencies. I'm not going to read all these for you guys, all these competencies right here. 28 things you should learn in this software. So look me in the eye if you did not learn all of them at the end. I'm going to pick, for example, we're going to be able to design lighting, power, and HVAC equipment circuits for commercial building. Right? Circuit them. We need to perform electrical load calculation for commercial building, perform lighting system calculation. These are the learning outcomes. So if somebody say, what the heck did you do with Chad for this particular class? You grab these 12 and said, here's what we learned. Does that make sense? They call them learning outcomes. Design fire alarm. So basically what I walked you guys through the narrative is layout fire alarm system for commercial building. You lay out all the components. To summarize all this, guys, you need to be able to draft, design, draft, specify, layout, fire security phone, data, power, lighting for a commercial building. With all the analysis involved in it. And you spare me reading through all this, so please go through them. Grading. How am I going to grade you in this project? Please look at the grading. So E1 through E10 setup. When I told you guys next week we're going to be setting up E1 through E10, 4 points out of your final grade is going to be dedicated to doing the sheets, basically setting up the sheets. Am I making sense, guys? And you're going to see me putting grades. And each, like this assignment is 10 out of 10. When I say, if you look at my done, when it says 10 out of 10. So I'll give you 10 out of 10 for setting them up. These 10 out of 10 will count as 4% out of your overall grade. You guys are familiar with that. Okay, then Microsoft project, then electrical load, then all the assignment they're going to be doing with me. And can you guys see that? Every single assignment here is assigned a certain percentage of your grade. And please bear me reading all through them. You guys will read them in your own time. Generator sizing, for example. Pick on gen. When I say gen size, I'll give you 10 points out of it. So when you get 10 out of 10, 10 out of 10 will count 5% out of your final grade. Am I making sense through all of them? Then portfolio, when you do your binder, guys, is 3% out of your final grade. And the presentation, all your presentation, that fancy presentation that you're going to do is only 3% out of your final grade. So if you got with me, you could get 97 and get A plus and get 0 in the presentation. But don't do that though. So you, huh?
Based on public speaking or
I have never. I typically, there are 2 evaluations happen. One, the industry evaluates you. They evaluate you on public speaking and knowledge. And there's my evaluation. I evaluate you on personally on the ability to convey what you design. The knowledge, I know what your knowledge is. You spend already 18 months with me. I know what you know about your project, what you don't. So that's why my grading is different than the industry. The industry, they see you through these 10 minutes. So they evaluate you based on knowledge, technical knowledge, and ability to talk and convince the people. And they typically lower than mine. Their grading, you know, they kind of harsh a little bit. So if you got 6 out of 10, don't scare it too much. The average might be 7. But you know, it's a chance for all of you guys, and most of them, they know what we're doing, guys. They're not coming here to slice you or anything else. Okay. Yeah. So, any comments, guys, about the grading? How are we going to grade this this system? So when I say, Tony, my friend, when I say E6 floor plan power receptacle, when you're done with it, I'll give you 10 out of 10. That counts as 4%. And the way we do this assignment, guys, you do it. You and I will redline it. I'll send it to you to correct it. When you correct it, you bring it back to me, and I'll give you the grade. So, And typically, if it's 10 out of 10, you'll get 10 out of 10 if you corrected it after you and I looked at it. So it's really not hard to get the full assignment. Okay, to get the A plus with your friend Chad, you need 95, and I've never given anything less than a C. So this is where you see basically C between this and this. Academic honesty and plagiarism and what's not, guys. There's nothing here to plagiarize. All the information I need is in front of you. Do a good job, and you guys are here to get a career. So I hate it. I hate that you leave out of here, you don't know how to do load calc. You go work for somebody because you got load calc from your friend, and to give it to Chad, and then you're stuck, you'll be laid off because you don't know how to do it certain days. These are knowledge, guys, important for you in the field. Get it? Make sure you know how to use it. Ask me, ask everybody. It's not rocket science, but know how to do it. Lighting calculation, I used to tell the people, when we used to do teams, one person will not do lighting, then they go to work and they want him to do lighting, and oops, well, Chad told us that you did lighting. Well, my partner did lighting. Well, you should have done the lighting. So anyway, so all this one, guys, the rest is the same. The schedule that I have at the end is the same schedule I just walked you through. Exactly the same schedule. Any comments, any questions about this syllabi? Okay, let's go to the next document, please. In the same tab. Oops, there you go. So let's go to the theory now. Here's the classes, guys, for the commercial project. We have a lab. I just walked you through it. Here's the theory. The theory is code, and the calc is calculation. So we split the calc and the theory. In residential, I mix them up. In a commercial, I split them. So let's go to the theory. Here's the syllabi that I would like you guys to look at. The same information here. This is theory. If you read through this one, guys, we give you enough code information and explanation to design power, lighting, and low voltage based on NEC code book and other standards. That's what this class is all about, lecture. It's 3 credits, 54 hours, contact hours. The book for this class, guys, is this guy, the commercial. This is the one I'm looking at, 15. And also that you need the NEC code book. You guys have bought this. And you need the NEC code book, which is this guy. So these are the 2 books that you need. There's core abilities, the math and communication that the college need you to do. You guys typical. This is what you're going to learn in this. Explain service, entrance, conductor, feeder, branch circuit for commercial building. Instead of, and so you're going to be sizing, explaining them, and designing them. Am I making sense, guys, about these 3 classes that we teach you in the commercial? Take a service, for example, service entrance conductor. We take one class, what is a service entrance conductor? That will be the theory. How do you size a service entrance conductor? That will be the calc. And go size a service entrance conductor in your project. That's your project. Am I making sense? How one knowledge, we hit it from 3 locations. One, what is it? Then how do you size it? And after that, at the end, when you know what it is, how to size it, go put it in your project, draft it. So these 3 classes go hand in hand together. You know, that's why you can't do the project without doing the theory and the calc, because we explain the service. Because, okay, do the service. Well, I don't know how to do the service. What is the service, Chad? You know what I mean? So all this information, guys, the competencies, security system. What is security system? How is it put together? Fire alarm, phone, data, ATS, analyze commercial building plans and specification. All these information I'm going to get. How am I going to grade you guys? I have 4 tests and classroom engagement 10 and homework 10 and a final. This is your 100% grade in this project, in this class, in this theory class. So classroom engagement, you engage with me and with the industry and what's not. I typically give you a grade for it. Same grading system. I want to go all the way. You know, classroom engagement is specified right here, exactly like we did, guys, in the commercial project. Cooperation, coordination, research, share material and knowledge, and employment lead, attendance, computer. I don't count the computer shutdown here. Positive attitude, neat, clean, and organized desk. That's count towards your 10% of classroom engagement. I would like you guys, all these classes, I would like you to attend 95% of the time. We talked about this one last time. Okay, the most important thing, guys, in this syllabus is the class schedule. Can you guys see the class schedule at the bottom? And we talked about it yesterday. So that will tell you what does Chad wants you to do. So starting with this week, we're doing chapter 1 and 2, an introduction, all the way into chapter 18, oops, which we're doing. Can you guys see where homework 21 and 22 is due? That's what it's due. And we have the final exam in chapter 1 through chapter 22. That's your kind of guide through this class. Okay, comments, questions about this class, gentlemen? No? Okay. So I'm going to close this one. Close this one. I'm going to go to the last document that you have under this tab, which is the syllabi for the calc. This one here. By the way, when we do calc, guys, when I have a homework for you, the answer for the homework will be right in here. Do you see where homework? Lectures, I will put my lectures in this area for you. Do you guys see the lectures for calc and theory? I put my lectures there, and if there is a homework, when you do your homework, what is the answers, Chad? I will scan the answers and put them under homework there. Does it make sense? So that's how I do the classes. All my lectures will be there after we go through them. And then the homework answers after you submit them to me will be there too. Make sense? These what homework and then the syllabi. Here's the syllabi. The syllabi for this class, guys, this is a calculation class. Your goal is to be able to do the calculation for anything related to commercial project. The class, I did not ask you guys to buy this book, Mike Holt's book, this time because we only use one chapter out of it. But I asked you to use the lighting, step-by-step lighting calculation, this guy. The calculation book is divided into two sections. Section number 1, guys, we're going to go through this book. This is how to do lighting by hand. Nobody does lighting by hand anymore. The reason why we do it, we explain it to you guys to understand how do you do a foot candle calculation. It's nice to know how to do it by hand. Then, when you learn how to do it by hand, we switch into visual software and we do everything by software for the project. But I would like you guys to do a couple of formulas, use a couple of formulas here. So if you see a floppy disk at the end when you come here, so these don't be said, I've lost that. They still have floppy disk when they sell them. It's an old book, they don't make it manufactured anymore, but I really like, yeah, floppy disk. Do you remember that? You probably don't remember the floppy disk. Remember? Okay. So don't be sweating, it is small, cheap book, just to walk you through the theory of lighting calculation. Okay? So that's the two books that we need for this. And then if you guys need electrical exam prep, that class, I have a book, but I don't ask you to buy it because I only do 2 chapters on that from Mike Holt's electrical exam prep. We use them for the exam prep too. So I grab load calculation from it, and I'll put the lectures for you online, so you don't have to buy that book. It's only 2 lectures. Okay, what do you need to learn in this stuff? Everything here is about calculation. You have to need to be able to size branch circuits, size service, size feeder, size panel, size, everything sizing. I mean, you graduate from here and say somebody have a building and you need to size a service for it, you should be able to size service. They need a branch circuit for an air handling unit, you should be able to size a branch circuit for an air handling unit. So everything is about sizing them. All the stuff that we're going to do. Grading is the same, gentlemen. You can see it the same way we're going to be grading you, same like a theory. The last thing I want to go is the schedule. This is how we're going to run that. And when I say chapter 11 and chapter 12 here, please, can you guys see these two where it says chapter 11, chapter 12? These are from a book. These are from a book that you guys don't have. So don't worry about it. I didn't ask you to buy this book. So these are calculation that we're going to be doing from a book. And then we're going to move into after week 4. In week 5, we switch into lighting. Can you guys see that? In week 5, we switch into that book that you guys bought, that guy, the lighting book. And we do chapter 1 through chapter 16 in this lighting book. Chapter 1 through chapter 16 in lighting book. You can see when the test is going to be, roughly. Things will change. I will be pulling this information, guys, weekly and putting it there. as I told you yesterday. So that's basically what you're going to be learning with your friend Chad in this particular class. Any comments, guys? Any questions? To summarize, you guys are going to be running this semester two projects, one commercial, one residential. The residential has a lecture that goes with it. And the lecture for the residential is theory and calc. For the commercial, we have two lectures, one calc and one theory that support the project. That's what we're doing and what we're cooking for you guys. So that's all what I have, guys, to introduce the project before. So just a quick reminder, when you go to the commercial project, again, the lectures will be here after we do them, and the homework will be here. So all the PowerPoint presentation that I will go over, guys, after I go over them, I will dump them into the lecture for you to look at if you want to. Am I making sense how the interface is going to be? My expectation for you guys for the homework is here's team number one, is you go under, did you already did these? Okay, are this for your homework or?
You told us to make.
Folders.
For each class.
Oh yeah, is that, yeah, so you put all, these are your folders. So he put folders here for his homework. And so your homework will be in your own team folder. So this is as easy. Yeah, right click here and put new folder. Homework one. Perfect, and that's what I would actually. Yeah, that's what I would do there. So here's I'll walk you through it, don't worry. So even if you put them here, I just want you to be organized here. If I were you here, if you don't mind, I would probably here, here's a folder, call it homework. This is just for the homework, right? And then drag these, see how, and you put them right into the homework. That's it. So you'll have one homework, one folder. Do you see guys how I did the folder? Right click on it, and then here's my homework for each one of these assignments. Yeah. Yeah, if you know, as long as you make it clear, you would. I'm sorry, Gary.
I don't have a students folder in my network. Let me put my network.
Go back.
I have nothing in there.
You have to take that from an email that he sent us.
Oh,
Oh yeah, there's a link.
Oh, you did not have the link?
We don't even have that stuff yet. We created our computers there and put it there.
Were you able to go to yours?
I got my computer yesterday, but I didn't.
Ah.
I don't remember how to take the email and create all the team folders and stuff.
Highlight it.
Where do I put that? So, I don't know
Everybody knows how to do that. Let's go to the instructor folder. If you guys go to the instructor folder, please, and I would like you to look at the Revit families because that's where you're going to be picking up stuff. One more time, go to the instructor folder and give me a thumbs up when you see what I see right now. Everybody can see that? Good, good, good. Okay. Now, right in here, gentlemen, there is Revit families. Can you guys see that folder? This is going to be very important to you because when, for example, Gary, you're looking for, do I keep picking on you? So for example, you're going to be going in air handling unit, Chad. Where can I find an air handling unit, Chad? Where are you? In Revit? Yep. Go to the Revit family. That's your first stop. Okay, click on Revit family, will you? When you go on the instructor folder, got it? Okay, when you click there, everybody's there? John? Okay, I'll wait. Instructor folder. Go back one step.
Don't you have a shortcut on your desktop?
Where's your shortcut? Look. Yeah, well, here is your shortcut. Oh, there you go. Did you guys get your milk this morning or what?
if you, if
Told me everything the first time.
I know, I know.
Especially the first conference,
I know. Don't worry. We're here, man. This is day 2. Remember, after day, we'll talk after 18 weeks.
Okay, let's go.
You keep doing that. Listen, no, you're paying me, man. You can ask me as much as you want. This is your time. Um, but I think so. I think your background, that black, makes it really hard to see. I was looking too. It's hard. Okay, when you guys go there, instructor folder, the most important thing for Revit, the Revit family. So please click on Revit family. You're going to see the following folders. So important. I'm going to go over them. Annotation. Annotation is tagging. Remember that when you want to, you have a receptacle, you want to call this receptacle fit from circuit 1, panel 1. That's called tagging. You tag it. Annotations are tagging. So if you want to tag, you always go to annotation. If you click on annotation, here's all the families that we have to tag things in Revit. These are Revit files. There are, I'm going to look at description. So we have a fire alarm. We have, and I'll walk you through feeder. We have fire alarm exterior tag. We have mounting tags. We have panel tags, switches. So, and don't worry about which one to use where. I'll walk you guys through that, but be aware, if you want to tag something, tag means write something next to something, next to a symbol. That's what a tag is. Write like GFCI next to it. Okay, so that's where we're gonna go. Annotation. Appliances. If you go under appliances, fans, air dryer, handle dryer, heater. These are what we call them appliances. If you go under control building, communication, connectors, data, electrical equipment. I'm going to click on electric equipment. If you guys go under electric equipment, look what you're going to see. You're going to see duct, bus duct, generator, MCC, motor control devices, panel board, transfer switches, transformer, UPS. Let's click on the UPS. For the UPS, guys, you're going to have a UPS family, a UPS with a battery, PDU, emergency power off. And some of these you might doesn't mean anything to you, but when we're doing, I'm going to go back to panels easier. Panels. Can you guys go to panels, will you please? Go back one step and go to panels. Here's all the panels that we have, family panels. Revit has a lot of families, like I said. When I see panels, okay, what type of panel do you need, Chad? Okay, let's look at this one. This is panel 208 MCP. Anybody knows what MCP is? Main circuit breaker. And I'll go over these. Main circuit breaker, surface mounted. Very clear. You need a panel, 208, main circuit breaker, and surface mounted, right on the wall. Now, right underneath it, gentlemen, this is a panel, 208, main circuit breaker, and this is main lugs only, MLO, no main in it. It's just lugs. And I'll tell you when you need to use them. Surface, if it's not surface, it's typically recessed. If it doesn't say surface, it's what? Recessed. So that's recessed. Right? Here's a recessed one right there. Look at the 480. Do we need to use any of these 480 in this project? No. But remember, these families are for 2 projects. This project and the spring. You guys are going to be using the same families. So this will give you guys all the families about the panels that you have here. And again, we'll use them as we go. Fixtures. I'm going to go directly into lighting fixtures. I went back all the way to lighting fixtures. Here's all the lighting fixtures that we have for you, the families. Acuity brands. We even have Acuity brands for you. And deeper, you can click on tons and tons of these. So, but most of the stuff that you need is really right in here. So, gentlemen, without confusing you too much, I want you to know right in here under Revit families, all the families that you need for the 2 projects, the industrial and the commercials, are here. So, and which folder are you going to be searching for when we go do power? I will let you know if you're doing, for example, if you're doing panels, that will be electrical equipment. If you're confused which folder the information is, ask me. Till you go to this folder, you'll find it there. So these are the Revit families. Families are symbols that we're going to be using for this project. Does that make sense? So this folder is going to be your friend. um, and how do you load them to your project? I'll show you later and after the break, guys, how we open Revit and load families and bring them and what's not. Okay, so that's all what I want to show you guys. Any question about the online folders? Everybody understand how they work, how you put your homework there, how you interface with me, how I interface with you by putting the lectures there? Gary, makes sense? Yes? So far. The devil is in the details always. Okay. All right, let's take a quick break, guys, and we'll flip into Revit here.